Good afternoon, everybody. My name is Amy Gray and I am a second year PhD student based at Loughborough University. I've developed a short video for you guys today which outlines my project, gives you a little bit about the rationale behind it, and also gives you an idea of what it's like to be an Arctic scientist. Since the formation of our planet 4.5 billion years ago, it has existed in an ever-changing state of flux. But it wasn't until the evolution of humans around 500,000 years ago, and more importantly, our recent reliance upon fossil fuels as an energy source, that our planet's natural fluctuations have been overridden. Climate change is arguably the greatest threat our species has faced in thousands of years, and it is our continued dependence upon fossil fuels that is to blame. Indeed, the average global temperature has increased by over 1 degree Celsius since 1880, with climate models predicting that by the end of the century, the average global temperature will have risen anywhere between a further 1 degree C or 4 degrees C. The knock-on environmental impacts will be profound. Not only that, but the burning of fossil fuels releases contaminants such as sulfur dioxide, nitrous oxide, and polycyclic aromatic hydrocarbons, a type of particulate that can circulate far around the world in the atmosphere, leading to widespread pollution. Even the cold and distant Arctic has not been able to avoid these man-made climatic and environmental impacts. Shrouded in darkness for 2.5 months of the year, and with temperatures between -13 and -20 degrees Celsius during the winter period, the remote archipelago of Svalbard is starting to show signs of change. Atmospheric pollutants are deposited onto the ground in the form of snow and ice, where they can remain trapped for many years. Glacial ice covers 60% of Svalbard's landmass, so there is a lot of potential for glaciers to act as a storage unit for pollutants, both past and present. With climate change in the Arctic anticipated to take place at twice the rate of the global average, climate change is expected to play a major role in changing the face of places like Svalbard and potentially releasing trapped pollutants in the process. This seemingly pristine environment suddenly becomes not so pristine after all. With melting snow and ice, contaminants are released into the wider environment in the summer meltwater, where they follow the gradient of the land down into Arctic lakes, or indeed out to sea. During the water's journey from its frozen source, it also picks up more passengers, like sediments from the landscape or fragments of plant material, and these remain suspended in the turbulent waters until they reach a destination where they can settle out. This destination will most likely be a lake or the ocean, and over time, this settling process results in a gradual build-up of layers of sediments on the lake and ocean floors, which can provide a snapshot of information through time, detailing past environments. And it is here, deep below the icy Arctic waters, that my part of this journey begins. As Tessa said in her presentation yesterday, lake sediments have the potential to provide lots of information about past environments if you know what you're looking for. So that's what I'm planning on doing with my research. I've collected lake sediment cores and marine sediment cores, and I'll be bringing them back to the UK to analyse them to try and reconstruct past environments. My research is taking place in Svalbard, an archipelago in the high Arctic. In particular, I'll be working in and around Ny-Ålesund, a research village that is considered to be the most northerly town in the world at 79 degrees north. As you can see from this map, I have 9 sediment core collection sites, 6 of which are ocean-based, and the remaining 3 are in and around Ny-Ålesund itself. Focusing on the ocean-based research first, I collected my marine sediment cores in October of 2018. I underwent a voyage on the Helmer Hansen, the ship that you can see in this photo, which is a research ship that had all the equipment needed to collect the cores that I'll be using. I'm going to be focusing on the 2 collection sites closest to the village of Ny-Ålesund for my PhD. Now, looking at the lake collection sites, you can see that there are 4 identified. We decided against the most northerly site because we didn't have time to transport the equipment to the lake. However, the other 3 were suitable, and we collected these cores in July 2019. As you can see from the pictures, working in Svalbard is amazing. It is a beautiful, remote, rugged destination. To collect our lake cores, we used the dinghy pictured in the top left photo, and suspended the kayak corer, which is a type of corer that we used, down through the lake waters to collect the sediments from the bottom of the lake. These sediments were transported back to the UK for analysis. Perhaps one of the most important things that you have to learn as an Arctic researcher is how to defend yourself against polar bears. There is extensive training when you arrive to do your research in Svalbard that requires you to learn how to use a rifle and a flare gun. The flare gun is the first line of defence, the rifle is the last resort. But as you can see from these photos, polar bears are very much a presence on the island. Working in an Arctic environment can be extremely challenging, not least because of the weather conditions. They can change very quickly. You can see from this photo that we had to wear some very bulky flotation suits that were designed to both keep us warm and keep us afloat should the boat capsize. It wasn't easy to move around in, and when you're hiking in these pieces of equipment, it can be very hot. Equally, it can suddenly turn very cold, so you have to get used to being very flexible when it comes to the weather. Both my marine and lake-based field seasons were successful, and I have a number of sediment cores back at Loughborough University ready for analysis. I'm going to be looking at the changes in sediment type down the core, the chemistry within the core, how much organic carbon there is at different parts of the core. I'll be looking at diatoms, the algae that Tessa was talking about yesterday, to try and determine what the environment was like in the lakes through time. And ultimately, I'll also be looking for pollutants within these sediment cores. This will help me understand whether or not man-made pollutants have reached this far north in lake sediments and what the impact has been on those lakes. I've started my analyses by looking at total organic carbon content down the core in a process that is called loss on ignition. You take certain amounts of your sediment, measure them out, and then burn them at 550 degrees Celsius to burn off the organic carbon. The amount of weight lost will then tell you how much organic carbon there was in your sediment. This is just the start of my analyses, and I'll be looking at analysing the different algae that I'll be finding in my lake sediments, sending it off for chemical analyses so I can determine whether or not pollutants are present, and getting my cores dated so I can have a concept of where in time I'm looking. All of these things lie ahead, and I hope that next time I present to you at the CENTA Conference, I'm able to provide some exciting results to share with you. Thank you very much for your time and attention.